So yesterday you guys talked about classifying triangles such as acute, scalene, or right isosceles. And the idea was acute meant all the angles were less than 90. Right meant that you had one right angle. Obtuse meant you had one obtuse angle, so one angle that was larger than 90 degrees. And equiangular, which was all three angles exactly the same. And then a classification by sides, you had isosceles, which meant two sides were the same. You had equilateral, which meant three sides were the same, or you had scalene, which meant no sides were the same. And then one important factor was if it was one E word, it was the other. So if it was equilateral, it had to be equiangular. If it was equiangular, it had to be equilateral. You also learned about the fact that the three angles inside of a triangle add up to 180. Today we're going to go one step further with triangles and polygons, and we're going to talk about congruent polygons. So congruent we know means the same. So if we're talking about congruent polygons, we're talking about polygons that are the same. So if I look at these two examples, the first example shows you three polygons that are identical. So when I look at figure 1, figure 2, and figure 3, they're exactly the same size, they're exactly the same shape. But when I look at the second grouping, we notice that 4 is really big and 5 is really small. So although they're the same shape, they're not the same size, which means they are not congruent. So when we talk about congruent polygons, we're saying that they're exactly the same size, exactly the same shape. So in order to make sure that that happens, we have to have every side that matches up be congruent, as well as every angle that matches up be congruent. So that means every side matches up to a side in the other shape, and every angle matches up to an angle in the other shape. So when I look at these two pictures, I can see that angle B is marked with one angle, and also angle J is marked with one angle mark. So those are corresponding angles. They should match up and they're congruent. We see that angle A has 2 marks, just like H has 2 marks, so that those match up and they are congruent. And then notice that C and K are. So when that happens, we can write what we call a congruence statement. And a congruence statement just says that one triangle or one polygon is congruent to another. So in this case, it's going to be triangle ABC is congruent to triangle. So notice we went from 2 marks to 1 mark to 3 marks. So we're going to do the exact same thing. We're going to go from 2 marks to 1 mark to 3 marks. So HJK. HJK. So whenever we have congruent polygons, we can always write a congruent statement saying that they're exactly the same. So because they have to be in the right order, we can do things like example 1. So example 1 gives us this nice congruent statement, and we're going to list all of the congruent sides and all of the congruent angles. So I'm going to start with angles because that's the easy part. I notice that C is the first letter of the first name and J is the first letter of the second name. So that's telling you that angle C is congruent to angle J, and I can mark C congruent to J. Then A is the second letter, and that matches up to S, which is the second letter in the other name. And that leaves you with the last letter T congruent to the last letter D. So again, we can mark A the same as S, and then we can mark T the same as D. So now we're going to do the sides. So when I look at the sides, we're going to look at the first 2 letters. So that's going to be your CA, and the first 2 letters is JS. So CA is congruent to JS. Now we're going to look at the middle 2 letters. So your middle 2 or your last 2 letters are AT and SD. So AT has to be congruent to SD. And then your last set, so that's going to be the first letter and the last letter. So that's going to be CT is congruent to the first letter and the last letter. So JD. All right. Because they always have to be in that order, we come up with the acronym CPCTC. And this is a bonus question on your test. And CPCTC stands for corresponding parts of congruent triangles are congruent. So CPCTC stands for corresponding parts of congruent triangles are congruent. So in other words, if I know the triangles are congruent, then I know that every part of that has to match the other shape, and I can match those up like we did in example 1. All right, and so that allows us to actually do examples like 3 and 4. So again, we're given the congruency statement, and we're going to find x and y. So when I look at this picture, and I look at, we're going to move the picture over a little bit. Okay, so when I look at this, and I want to look for x. So x deals with this side, mn, and I look at the congruency statement. mn is the last 2 letters, so I look at the other one, and it should match up to fg. So I look at the picture, here is fg. So I know that 5x plus 2 is supposed to be the same as 12. So we just subtract our 2, 5x equals 10, and we're going to get x equals 2. We're going to divide both sides by 5, we get x equals 2. All right, so the next letter is y, and y is actually supposed to be here at angle L. So I know y is angle L. So again, we're going to look back up here at our congruency statement here, and we are going to look at angle L. L is the second letter. It should match up to E, which is the second letter in the other name. So that means 5y plus 6 is supposed to equal 111. Subtract your 6 from both sides. 5y equals 105. Divide by 5, you get y equals 21. So we use the congruency statement to figure out what pieces are supposed to match. So in the next example, same thing. We're given a congruency statement. We're going to find x and y. So I look for x. Here is x. Well, there's a problem there. That has an x and a y. So that's not going to help us. Let's look at y first. Y goes with angle F. So I look over here. Angle F is the middle letter. That is supposed to match up to B, the middle letter in the other name. So it has to be 99. So we're going to have 8y minus 5 equals 99. Add 5 to both sides. We get 8y equals 104. And then we're going to divide both sides by 8. So you're going to end up with y equals 13. All right, now we can go back up here, and we know that this is 2 times y, but we know that y is 13. So this is really 2 times 13, which is 26, plus x. So FE is going to be my last 2 letters. I'm going to match that up to BC. So here is BC. Those have to match, so I'm going to get 26 plus x equals 38.4. 38.4. All right, so I'm just going to subtract my 26 from both sides. And I get that x equals 12.4. All right, the last theorem here is called the third angles theorem. And the third angles theorem basically just says, if 2 angles in one triangle are congruent to 2 angles in a second triangle, then the third angles must be congruent. And that should kind of make sense. So if we look at 2 triangles, and the first triangle, let's say it has an angle of 50 and 60, and the other triangle has an angle of 50 and 60, I know that the angles have to add up to 180. So 180 minus 110 tells you that this angle is 70. And the same thing happens here. So that tells you the third angles have to be the same, and that's all that that theorem is for. So today all you have is the worksheet to do, and we're gonna, in the next video, I will talk a little bit about that worksheet.